Can you see the screen?
Yes, sir.
Yes, sir.
Okay, so last time we discussed about functions, right? One function or injective function. So what is injective function? So function is one or injective if distinct elements in domain are mapped to distinct elements. So distinct elements have distinct images, or if 2 points are not same, then their images are also not same. That is what the meaning of one function. So if you look at graph of function, then if 2 points have same image, two distinct points x1 and x2 have same image, then their y coordinates is same on the graph. And the y coordinate is same, that means they are at same height. They are at same height means if you draw a horizontal line, then that line intersect at two distinct points to the graph. Right, so this is a horizontal line test. So if you draw a horizontal line, and if there exists a line which intersect graph at two distinct points, then corresponding points are the images of two distinct points. So corresponding x coordinates are two distinct elements in domain whose image is same, right? So this is clear, horizontal line test.
Yes, sir.
Yes, sir.
Right, so last time I gave you the functions examples. Right, so if you look at these functions, so just a minute, something is. So okay, can you see the screen?
Yes,
Yes,
sir.
sir.
Okay, so if you look at graphs of these functions, then from these graphs you can understand if you look at sine graph of sine function, so this function is not one because there are many points at same level, right? But if you look at a function on restricted interval minus pi by 2 to pi by 2, right? In this range, graph of function is this, right? And therefore, in that case, it is 1 because if you draw any horizontal line, that line intersect only at one point, and therefore distinct elements have distinct images. So if you look at exponential function, so what is the graph of exponential function? You know, graph of exponential function. This is graph of exponential function e raised to x, and at 0 it passes through 1. So this corresponds to 0, 1. Right. So is it 1 function from graph?
Yes, sir.
Yes, right? Because if you draw any horizontal line, that line will intersect exactly at one point. So, do you know graph of log x?
Yes.
If you look at graph of logarithmic function, how is graph of log x? Right. And so this is graph of log x, and is it 1 function?
Yes, sir.
Yes, sir.
Yes, right. So at 1 it passes through at 1 it passes through 0. So uh, log x is 1 function. And what is domain of log x? Domain is
Real number greater than 0.
right. So positive real numbers only. For negative real numbers, log function is not defined. Now, what is graph of absolute value x? Graph of absolute value function. So fx is equal to absolute value of x. Right. So it is x for positive numbers. It is minus x if x is negative, and 0 if x is equal to 0. So if x is positive, it is same as y is equal to x. If x is negative, it is same as y is equal to minus x. Is it 1 function?
No, sir.
No,
No.
right? And therefore, from graph itself, we can understand whether it is a 1 function. Also, last time we discussed the one more test, that is vertical line test. So what vertical line test gives? What information vertical line gives?
To determine the is it function or not.
Yes, right. So vertical line gives us information whether that graph is a function or not. So so what we discussed last time. So f defined on A to R is 1 or injective, right? So function is 1 or injective if uh, for x1 and x2 in A. If x1 and x2 are distinct, then their images are also distinct, right? So this is equivalent to saying that is. So what is a contrapositive statement to this? Contrapositive statement means what? So you note this, key P implies Q is equivalent to saying that is equivalent to what?
Negation
Negation of
Q, then negation P. Negation
negation
Q,
of
then.
P, right? So when we say P implies Q, it is same thing. Negation of Q implies negation of P, right? So if P is true, then Q is true. It is same as if P is not Q is not true, then P is not true. So logical way to say this. So here what we have, what is statement P in this situation? Ki x1 is not equal to x2 implies fx1 is not equal to fx2, right? So x1 is not equal to x2, then fx1 is not equal to fx2. So what is the contrapositive statement? So what is the contrapositive to this, right? What is the contrapositive to this?
F equals to x2, then x equal x1 equals to x2.
So f is 1, if, when we say f is 1 1, if x1 is not equal to x2 implies fx1 is not equal to fx2. So what is a contrapositive? Fx1 is equal to fx2. If images are equal, then what? Pre-images are also equal. Right? So if images are equal, then pre-images are equal. It's same thing that if images are pre-images are unequal, then images are unequal. So this is what the way you can say. So so therefore f is 1 1 if x1 images are equal, then pre-images are also equal. So that means distinct elements must have distinct images. Right. So let us see some non-trivial examples. So if I define f from R to R, fx is equal to x. How will you prove that it is 1 1? Prove that f is 1 1 on R. Right, everywhere on R. So if you look at graph of f of x equal to x, it is a straight line. So clearly it is 1 1. So why it is 1 1? Right. So for x1 and x2 any two real numbers, if fx1 is equal to fx2, what we expect then? Right. So if images are equal, what we expect?
X1 equal to
X
But
equal to X.
correct. So, but by definition, what is fx1? Is x1, right? And what is fx2? By definition, what is the value of function at x2? Is x2. So ultimately, we get that if fx1 is equal to fx2, then x1 is equal to x2. It is equivalent to saying that x1 is not equal to x2, then the images are also unequal. Right. So if I define another function f from R to R, fx is equal to 3x plus 2. Is it 1 1? Is it 1 1 function? So let us check. Choose any two elements and suppose their images are equal. Right. So what is the problem if two distinct elements have same image? Then function is not 1 1, right? Suppose there are two elements whose images are equal, and if elements are distinct and still images are equal, then function is not 1 1. But if images are equal, then there is no way that the elements are pre-images are unequal. So pre-images must be equal. Can we see this? So fx1 is equal to fx2. Then, but what is fx1 by definition?
3x.
Right, so 3x1 plus 2 and is equal to what is fx2 value?
3x2 plus
3x.
Now 2 we can cancel or I can subtract 2 on both sides or add minus 2 on both sides. So what I get? 3x1 is equal to 3x2. Right, I can multiply by multiplicative inverse of 3, or I will multiply by 1 upon 3 on both sides. So what I will get? X1 is equal to x2. So therefore what I get, if images are equal, then images are also equal. That is equivalent to saying that if images are unequal, then images are certainly unequal. So therefore this function is f is 1 1. Right. If you look at fx is equal to x square on R, is this function 1 1? Is it 1 1?
No, sir.
No, because if you look at the graph, there are many points. So if I take x1 is equal to -1 and x2 is equal to 1, then certainly x1 is not equal to x2 because -1 is not equal to minus 1. So, but what is fx1 is equal to fx2. So we have produced an evidence where the definition of one function fails. Right. So what is the evidence? X1 is equal to -1 and x2 is equal to. There are many evidences. Right. One can take x1 is equal to -2 and x2 is equal to 2. One can take x1 is equal to -half and x2 is equal to half. There are many evidences where the definition of one function fails. Right. Therefore, f is not 1. To say that not one evidence is sufficient on that domain, right? Not necessary how many evidences you have to produce. So to say that some statement is false, so logically one evidence, right? If all apples in the box are sweet, so when we want to make this statement false or to prove that statement is false, what is sufficient, right? What suffices to produce one evidence, one apple if we can produce from the box which is not sweet, then statement is false. Right. So if you look at fx is equal to x cube, x belongs to R. 1 1. Do you know graph of x cube?
Yes.
Right. This is a graph of function fx is equal to x cube. And from graph it is clear. But most of the times, sometimes it is not easy to sketch the graph of function because the definition of function might be complicated. Right. Here in simple case it is easy. Right. So how will you show that it is one function? Right. So let x and y are two elements, right? So that if fx is equal to fy, means what? Fx minus fy is equal to 0, right? Then can we say that x is equal to y? Right?
Yes, sir.
Yes.
Correct? From that, can we declare that x is equal to y?
Yes, sir.
Yes.
Is equal to 0. So when I say fx is equal to fy means fx minus fy is 0. That means x cube minus y cube is 0. That means now product of two things is two brackets is 0. That means x minus y is equal to 0 or x square plus xy plus y square is equal to 0. There are two possibilities. It may happen that x minus y is non-zero, but the second factor is 0. But in that case, we cannot declare that x is equal to y. Right. So the product is 0. That means either this first bracket is 0 or second bracket is 0. But there is no chance for second brackets to be 0. Why? Observe that. The second bracket cannot be 0. Why? Second bracket cannot. Why? Because
It is homogeneous equation.
why second bracket? Because you can make cases if x is negative and y is positive. What will happen? X is negative and y is positive. What will happen? Hmm?
X
Then what
square
happens?
plus x square will be positive and xy will be negative.
Yeah. Then x minus y is non-zero. X square plus xy plus y square is non-zero, and therefore x cube minus y cube is non-zero. So not possible. Correct? So x is negative and y is positive. In that case, x cube minus y cube is 0 is not possible. Is non-zero. But what is our assumption? Our assumption is x cube minus y cube is 0. This is our assumption. And therefore, one negative and another positive, this is not possible. So the second bracket, what I want to say is, uh, basically what I want to tell here is, so what I should say, if x is negative, y is positive, then x and y have opposite signs, right? Opposite signs, and therefore x cube and y cube also have opposite signs, right? Therefore x cube cannot be equal to y cube. Contradiction. Why contradiction? Because we are assuming that x cube minus y cube is equal to 0. That is our assumption. Suppose images are same, but if one number is negative and another is positive, and then the images cannot be same, so this case is not valid. That means, therefore, what remains if both x is positive and y is positive? In that case, what will happen? X square plus xy plus y square is strictly positive. Correct? What is third possibility? What is third possibility?
X is less
X
than 0,
is
y is less than 0.
Both are negative.
both are
Then what
negative.
will- both are negative. Then in any case, what will happen? If x is negative, x square is positive. Y is negative, y square is positive. And both x and y are negative, so xy is positive. So this expression is still positive. Right? Therefore, in any case, x square plus xy plus y square is not 0. Right? So therefore, what is the conclusion? Thus, what is the conclusion? Implies what is the conclusion? So what is the final answer? So is this clear?
X is equal to 1.
Right. So if images are same, then pre-images are same. That means if pre-images are distinct, then images are distinct. So therefore this function is 1, 1. From graph we could see easily, but by calculations also we can understand it better. Right. Okay, let A is equal to 1, 2, 3 and P is equal to A, B, C. Now, if I define function like this, so 1, 2, 3, A, B, C, right? So I will map 1 to A, 2 to B, 3 to C, right? So that means f of 1 is equal to A, f of 2 is equal to B, f of 3 is equal to C. So is it one function?
Yes, sir.
Yes. So it is one
Yes, sir.
function.
Yes, sir.
Right.
Yes, sir.
So now can you define any other one function from A to B, from same set A to B? Can you define any other? Can you define any other one function from A to B?
F of 1
f of x is equal to x.
So this is what f of x is equal to?
X.
How can you say this f of x is equal to x? What is f of 1 in that case? 1. Is 1 available in codomain? Right? If x is in A, then f of x is in codomain. And when I say f of x is equal to x, then f of 1 is equal to 1. Is 1 available in B? Right? Do you understand what I want to say? Is it clear? What is the problem? We
Yes, sir.
cannot say f of x equal to x in this case because A and B are distinct sets, different sets. So this is not possible in this case. So, but I can map 1 to B, 2 to C, 3 to A. So what is my function here?
F of
F
1 is
of 1
equal
is
to
equal to B, F of 2 is
F
equal to
of
C.
2 equal to C.
So is it one function?
yes, sir.
Yes.
Yes,
Yes,
sir.
sir.
Right. So now can you tell me one more one function from A to B, same sets? And this function, let us call this as G because this is a different function.
F of
Right?
1 is equal to C.
This is G, this is F.
1 to C.
Yes. So one more function.
F of 1 to C.
1 is related to C.
So I will define h of 1 is equal to C, h of 2 is equal to, h of
A.
3 is equal is
F H of
Of
3
2
is
equal
related to B.
B and here A. Right. So 1 goes to C, 2 goes to B, 3 goes to A. Right. This is again. Can you find one more? Can you find one more?
M of 1 equal to C, M of 2 equal to A, and M of 3 equal to B.
Okay. So I am defining new function. M of 1 is equal to
C,
C
M of 2 equal to A,
is equal to
A,
A.
M of 3 equal to B.
1 goes to C, 1 goes to C, 2 goes to A, 1 goes to C, 2 goes to A, 1 goes to C, 2 goes to A, okay, and 3 goes to B, right? Any new function? Phi of 1 is equal to phi of 2 is equal to Phi is just notation for function anyway. Or you can use some different notebooks. Can you tell me one more function?
One equals
Phi of 1 equal to B, phi of 2 equal to A, and phi of 3 equal to C.
Phi of 3 is equal to C. So one goes to B, 2 goes to A. Isn't it repeated? Just check it. 1 goes to B, A, 3 goes to C. Any more? Eta of 1, eta of 2, eta of 3.
Nasik Chapur.
How is
Today.
what should be the image? Can you find which is not equal to the previous ones?
Shuri. Nifad Kre. Of 1 equals to A, N of 2 equals to B.
1 goes to B, 2 goes to
B,
A, and 3 goes to C.
but that function is already we have considered
So
identity
1 goes to A, 2 goes to C, and 3 goes to B.
Yes.
right. Now if you sketch the picture of these functions and see how it looks. Right, so 1, 2, 3, A, B, C. So what this suggests, 1 goes to C, 2 goes to B, and 3 goes to A. Right, what this suggests, just sketch the picture 1, 2, 3, A, B, C. So 1 goes to C, 2 goes to A, and 3 goes to B. Fine. So what is next here? 1, 2, 3, A, B, C. 1 goes to B, 1 goes to B, 2 goes to A, right, and 3 goes to C, right. And what is next? 1, 2, 3, A, B, C. So 1 goes to A, this goes to this goes to this. Fine. So yeah, now you just look at this function. These three functions have some speciality. What these three star functions have speciality?
They are 1, 1.
No, all are 1, 1. All 6 functions are 1, 1, right? But these three functions are distinct because 2 goes to B. Second element goes to second element. Here, third element goes to third element, and here first element goes to first element. We are just switching 2 elements. We are just switching 2 elements. Here, third element goes to third element. We are switching 2 elements, right? Here, second element goes to second element, switching first and third. And all other are just cyclic, are moving in cyclic order. Cyclic means what? Now look at this double star function. Look at this this double star function, right? So what we are moving? So 1 goes to B, 2 goes to C, and 3. So we are moving in cyclic order. You understand? How many? So are these the only functions? 6 functions from A to B, 1, 1 functions, or anything else?
No.
No, right? These are the only. So how many 1, 1 functions are from these 3 element
6.
set to 3 element set? So right. So note that there are exactly 6 1 functions from 3-element set to 3-element set. Right, so this is a simple observation which we have. Now let A is equal to 1, 2, 3. Right, then my question is how many? Are there from A to A? So, how many distinct 1 functions are there from set A to A?
6.
6, right? Answer is 6. Because what is the basic thing here? Suppose we have 3 students and 3 caps, right? Set A is a set of all 3 students and B is a set of 3 caps. Then we want to distribute 3 caps to 3 students. How many ways you can distribute 3 caps among 3 students? The question is clear? Question is clear?
Ways.
Because what is a function? We are assigning elements of A with elements in B. Assigning means what? We are distributing. Suppose we want to distribute 3 caps among 3 students. How many ways? There are 6 ways. Right? And so one function uh, uh, gives 1-to-1 correspondence. So you cannot assign 1 cap to 2 students, right? Or we are not going to assign 2 caps to 1 student. So under this assumption, how many ways? So there are 6 ways, right? So if I take set A is equal to 1, 2 and set B is equal to A, B, C. Now question is how many? Are there from A to B? Right? How many 1-1 functions are there from set A to set B? Do you understand how many are there? And if you use your previous knowledge, simple logic, then what basically we are doing? So you have 2 elements and here we have 3 elements. So if you want to define 1-1 function, so to map 1, how many choices are there? How many possibilities are there to map 1 to some element in B? How many possibilities?
3.
3.
8, sir. 8.
3 possibilities, right? That means you choose one of them, A, B or C for 1. Once you selected one image of 1, for 2, how many possibilities are there? Because we want function to be 1, 1. So we cannot map 2. Suppose I map 1 to A. So I cannot map 2 to A, right? Because I want 1, 1 function. So how many possibilities left for 2?
2.
How many possibilities?
2.
2, right?
2 possibilities.
3 minus 1 because one element is already occupied by 1, so only 2 elements are remaining and therefore 2 has only how many possibilities? 2 possibilities, and therefore in total how many possibilities are there?
5.
5 possibilities.
So corresponding to every possibility of 1 there are 2 possibilities for 2, right? So 1 has 3 possibilities. Corresponding to every possibility of 1 there are 2 possibilities, so there are how many possibilities? Do you understand? Key 1 has 3 possibilities. Possibility 1, possibility 2, possibility 3. Right. So if I map 1 to A, if I map 1 to B, or I can map 1 to C, there are 3 possibilities forward. But corresponding to this possibility, what are possibilities for 2? B or C. So these 2 possibilities corresponding to this. Right. And therefore this gives me 2 functions. If I map 1 to B, then what are the possibilities for 2? A or C. So this gives me 2 possibilities.
A and C, two possibilities.
And 2 goes to A or B. So this gives me 2 possibilities. So 2 plus 2 plus 2. So in total there are 6 possibilities. Correct? And you can write down, for example, f of 1 is equal to A. Then what are the possibilities for 2? F of 2 is equal to B. So this is a 1-1 function. Right. Second, if f of 1 is equal to A, then what is the possibility for 2? C. So therefore f of 1 is equal to A, then this gives me 2 functions. Am I right? Is it clear what I want to say?
Yes, sir.
Yes, sir.
Yes, sir.
Right.
Yes.
So therefore, for every element, if you fix image of one element, then what are the possibilities for remaining elements? Right. So now I want to generalize this in some sense. Can we generalize this? Okay, let us consider another example. A is equal to 1, 2, and B is equal to A, B, C, D. Then how many 1-1 functions are there?
8, sir.
12.
12.
12.
12.
So for one, how many possibilities?
4.
4 possibilities, and for 2 there are 3 possibilities. In total, 4 into 3, 12. So there are 12 1-1 functions from A to B. And you write down all these 12 functions. Not difficult job, right? You fix just once you fix 1 goes to A, then you know what 2 goes to B, C, D. Three functions immediately will get. Correct? Okay, so
So how we calculate for 3 function?
how we calculate?
Means this method is apply for 3 function. Means A has 3 element and B has also 3 element.
Yes. Okay, let us take A is equal to 1, 2, 3, and B is equal to A, B, C. Then how many possibilities for 1? 3.
3.
How many possibilities for 2?
2.
2, right? And
2.
how many possibilities left with 3?
1.
Only 1.
1.
Because 1 occupied one element, but 3 ways are there, and 2 can occupy one of the from remaining 2 elements. And if 2 elements from B are occupied, then 3 has no choice, only one possibility. So total functions
6. Yes, 6.
right. Okay, now from this, if A has 4 elements, then how many functions from A to A?
24.
Right, so 4
24.
factorial. Do you understand? 4 factorial, 24, because by 1 definition of 1 there are 24. So now I want to generalize. If cardinality of A is n, right? Cardinality of A. Cardinality means what?
Number of elements.
Number
Number
of
of
elements.
elements in set A.
A. How many? One functions. From A to A. Right? So if I
n factorial.
one A has n elements 1, 2, 3 up to n. So first element has n choices because in codomain also n elements. But then 2 has how many choices? Because one element is already occupied by 1. So it has only
Minus
n
1
minus 1.
and minus 1.
Right. So 3 has n minus 2 choices because
Minus
2 elements are already occupied and therefore n has only one choice. So if you count all the ways, then there are n into n minus 1 into n minus 2, 2 into 1, which is n factorial 1 functions. Right. So you can think more about it. You can prove it also in detail, but right now we can just understand for simple sets. If A is equal to 1, 2, 3 and B is equal to AB, then how many? From how many 1
2 possible
functions?
2 1 functions.
Suppose we have 3
No
caps.
function possible.
Sir, it is not 1 function.
So there is no 1 function, right? Because if you have 3 caps and only 2 students, and I want to distribute all 3 caps among 2 students, and no student should get 2 caps. Is it possible? Right? If I suppose map 1 to A and 2 to B, what about 3? What about 3? 3 has no choice. 3 has to be mapped to either B or mapped to A. Right? Because no element is available in codomain. So there is no 1 function. At all. There is no 1 function from A to B at all. So if there are functions, okay, now my question is, next question, how many functions? From A to B. How many functions we can define from A to B? See, remember, how many possibilities for A1 are there? How many possibilities for 1? 2 possibilities. How
2
many possibilities for 2?
1.
1.
2 possibilities. No, because in general for function, no problem if you map to many elements to same point. That is not a problem for function. Am I right?
Yes, yes.
Yes, yes, yes.
Correct? And therefore 2 also has 2 possibilities. How many possibilities for 3?
2
2
possibilities.
2 possibilities. So in total, how many possibilities?
6,
8.
8.
8
8.
possibilities.
Correct? and you can actually write down all 8 functions, different functions from 3 element set to 2 element set. Right. If A is equal to AB, so how many functions? From A to A. How many functions are there from A to A?
4.
4.
4, right? Because A and B, A has 2 possibilities, B has 2 possibilities. In total, there are 2 into 2, that is 4 possibilities. So 4 functions, and you can actually write down all the 4 functions. Can you tell me what are the 4 functions? A, B, A, B. So this is identity function, right? This is one function. What is second function?
AB, BA,
B and B to A.
Right, this is second function. What is third function?
A and B both related to A.
All goes to A, right? What is
All
fourth
goes
function?
to B. All goes to B.
Right, this is fourth function and nothing else, right? These are function, but how many 1
Two.
Only 2 are
factorial, right? By our
2
previous
are
formula.
1.
So if cardinality of A is equal to okay, in previous case, cardinality of A is equal to 3, then how many functions from A to A? How many functions from A to A? We know how many functions.
27.
So
27.
suppose
20.
uh, suppose A has 3 elements, A, B, C. So A has how many choices? 3 choices. B has 3 choices. C has
27.
3 choices. Right, and therefore 3 into 3 into 3, that is 3 raised to 3, that is 27 choices. 23 right, 27 functions. Is it clear?
Yes, sir.
And you
Yes,
can
sir.
actually write down all these functions, but 1 functions are only 6. Right, so if cardinality of A is equal to n, then how many functions?
N raised to n.
A to A.
Two.
Because every element has n choices, and how many elements in a n? So n raised to n. Correct? If cardinality of A is equal to n, cardinality of B is equal to m, how many functions?
N raised to n.
A to B. Right, so has A1, A to n elements, and B has m elements. So B1, B2, Bm. So how many choices for A1? M choices.
M choices.
Enjoy.
How many choices for A2?
M choices.
M
Minus
choices.
4.
And in this way, how
M.
many times M choices will get? M into how many times? How many
M.
times M?
M.
N
N.
times.
M times.
Right, therefore it is M raised to N. Correct? Okay, so the question for exercise is find find a 1 function from find a 1 function from z to n. Find a 1 function n to z. Can you find 1 function from natural numbers to integers, integers to natural numbers? You just think about it, and next time we'll again revise the whatever we did in the previous problems. You just think about all these problems and try to write down in detail. Right, so next time we'll discuss about this. Okay, so any doubt, any difficulty?